Hello everyone, I am Mahdi Ghafourian, an EUIT and PhD student in Biometrics and Data Pattern Analytics Lab at the Universidad Autónoma de Madrid. In this video, I'm presenting our paper OTB-morph or one-time biometrics by morphing applied to face templates. Biometric template protection are a group of techniques that we are using mainly to preserve security and privacy of individuals' characteristics. Among them, cancelable approaches are very interesting due to their unique features such as providing revocability. However, cancelable templates of individuals, which is stored on template storage at the enrollment phase, do not change until either a predetermined due date or reporting a security breach. It happens this way because we need to offer user convenience. However, this issue breeds a couple of security problems. There are multiple attack points in a generic biometric system. In this study, we try to address three types of security challenges that is possible to be occurred in some of these attack points. Mostly, in biometric verification systems, anyone is permitted to request to be verified as the person they claim to be by guessing or obtaining the user ID or user code of the victim. As a result, biometric system fetch the reference of the victim from template storage to the matching module every time. This issue brings about the emergence of leakage attacks at attack point 3. Therefore, an attacker is able to obtain the similarity score in some verification sessions, not necessarily consecutive, and do iterative optimizations to maximize the similarity of an arbitrary face to that of victim. We observe that the attacker is able to lower the distance and get a high matching score in a small number of iterations. In addition to that, it is possible for an attacker to override feature extractor and inject a synthesized feature vector from attack point 2 and impersonate genuine user. To address these challenges, we propose one-time biometric which uses face morphing as transformation function. In a specific, in primary enrollment, when user face is captured, user input a random face image to the transformation function. These two images are then morphed together and the result is stored as user reference in template storage. Finally, the random image is recorded on user device. In each verification sessions, when user face is captured, the previously recorded random face is extracted from user device. Then, these images are morphed and the result is compared with the reference. If they match, user face is captured once more and morphed together with a new random face image. The result is considered as re-enrollment and it replaces previous reference. Finally, the new random face supersedes the previous one on user device. This process continues the same in next verification sessions. As a result, while the distance between two templates which were morphed using the same auxiliary data is low, that of morph by different auxiliary data is high. We implemented 4 different scenarios on CASIA and VGG Phase 2 datasets. From left column to right, not applying any protection method, applying Gaussian noise, applying imploding transformation, and applying the proposed method. The first row is the comparison of attack successful rate, while the second row shows the performance contrast. For both datasets, we observed that the falling rate of attacker matching score in the proposed method is quite lower than other scenarios. In a specific, it can be seen that while in all scenarios, the attacker matching score falls below 0.9 after only 40 sessions, it stands above that value for the proposed method. Moreover, the proposed method offers better performance as the overlapping region for imposter and genuine score is smaller. We achieved our result for EER and different FAR points. We observed that imploding has the worst performance. The highest attack successful rate are seen on scenario 1. Nevertheless, the proposed method excels in lowering attack successful rate and offering better performance. For example, in case of ASR at EER point, the value for proposed method is almost half of the worst scenario for both CASIA and VGG Phase 2. Thank you very much for your attention. Please do not hesitate to contact us if you have any question.